Hello and welcome to a new day. And we are going to go back at this particular example. I know period 5 has already done this, so period 4, this is for you. Anyway, so what we're going to try to do here is these particular problems, which from your homework would be 71 through 77. Got indigestion's really kicking in. I'm going to take a pill. Okay, so let's look at number 1 here. Focus, please. So number 1 here, it's asking us to find two functions that are a composite of one another. Okay? So basically, we are looking to see what the g of x was that we substituted in for the f of x. Okay? So before, on this other slide, we are taking these two and we are putting them together and simplifying them. Okay? For this one, we are looking at them that are already put together, and we are extracting the two functions. One function is within the other function. So, what do we have to do? Well, we're trying to figure out, what did I plug in? Does anybody have a guess as to what I may have plugged in? I actually wrote this problem, h of x, so you can see, kind of, what I plugged in. X plus 1 is what Luis Zuniga said. So he says that it's x plus 1. Now it looks like x plus 1 was inserted into something. Okay? But we have to compensate for both x's here. How could I have plugged in x plus 1 over in this area? Well, it looks like there's a negative and a negative. Maybe I could factor out a negative 1. So here we have h of x equals x plus 1. And I'm going to factor out a negative 1. And if I do that, I end up getting x plus 1. Huh. So I think Luis was right to say that g of x equals x plus 1. So if g of x was x plus 1, what would f of x be? Someone with a loud booming voice that has a hand in the air. That's not Luis. Elizabeth. X squared minus x. So now, let's think about this. I'm going to take x plus 1, plug it in, I get that. I take x plus 1, I plug it in, I get this. I would distribute it, go backwards, and I get this simplified version. Okay? Does that make sense? So you're basically doing composites backwards. You try number 2. And you watching the video, try number 2. It's what?
Cringy.
Is it a word? Cringe-worthy.
That's what I said.
I think.
Yeah, no, I said yeah.
Cringy. Okay. Well, identify f of x and g of x for me. Whether it's cringy or not. How's it coming over there, Jimmy? Do you need any sticky notes? And then when you're done with them, you can just put them into the book and leave them. Oh, cool. So that means, since those are already in there, basically every time you come in here, just check the late box to see if anybody has done anything late. And I don't dock late work. Sounds like we're done. Colin, what'd you get?
F of x, I got x plus 3.
So you got f of x equals x plus 3? No.
Because G of x.
What did you put for g of x?
X over x squared plus 2.
No. Cubed? Okay, a little bit closer.
You flip-flop idiot. You flip-flop them.
You flip-flop them.
Is actually G of X.
You have g of x up here and f of x right here.
You're right, my bad.
It's just your plugging.
Mistakes are okay.
You're right.
They're not what you did.
They are okay. Too much, you guys, too much talking, seriously, though. So. So anyway, the challenge of these type of problems is to find the domain. We're going to go ahead and skip that. You basically take whatever's on the bottom and set it equal to 0 and solve. Okay? So, careful with that. And remember, cubing numbers, negative numbers, remain negative numbers. Remember that when you're trying to find the domain. Do we want to find the domain of this? Do you guys understand what it is? Yeah? Okay, let's do it. So we get x plus 3 cubed plus 2. We say that it's not supposed to equal 0. Okay, because it's on the bottom of a fraction. So what I'm going to do is I'm going to solve for x. I'm going to subtract 2 on both sides. X plus 3 equals that, which is, no, not yet, which is negative 2. I'm going to cube root it. I'm going to subtract 3. And it turns out that we get all real numbers, but x cannot equal the cube root of negative 2 minus 3. And that's some decimal number that'll work. Alexis?
How do you tell which one is G of X and then F of X?
How do you tell? Well, the one we plug in is going to be g of x. The one that I've plugged into this equation, I've plugged it in here, and I've plugged it in here. And everywhere you plug it in, that's the x of f of x. So I've plugged in an x, I plugged in x plus 3 for x, and I plugged in an x plus 3 for x here. And that's why we get f of x as x over x cubed plus 2. Yes? No. Because the cube root can be minus. So you don't have to compensate for that. See, why we compensate for x squared is because x squared, you can plug in two numbers to get an outcome of the same number. Negative 2 and positive 2, they both squared to be positive 4. However, the cube root, negative 2 cubed is negative 8, and 2 cubed is positive 8. They're unique solutions. However, when you have negative and positive, they are not one-to-one or unique. So that's why. All right, so let's move on to some profit revenue stuff. This was an example, and these were more of the word problems that were at the end of your homework that maybe you did or did not get to. And frankly, they're not too bad. You are just doing composites of them. So it says a demand function for a certain product is P, which equals f of x, which equals 50 minus 0.05x, where P is the price of the product when x units are sold. The cost of producing x units is given by C of x, and that is 0.09x plus 12,000. Find the revenue function, which the revenue function is R of x equals x times f of x. Okay, that would be x times 50 minus 0.05x. And so basically we get 50x minus 0.05x squared. And now we have to figure out the profit that a business would have. That's what we do. We take the revenue, we subtract it by the cost, and we figure out how much we make. Okay? The revenue function is basically how much you earn from a product. For instance, this hydro flask. If I was the person selling this, the revenue that I would get, $25. Okay? But we have to figure out the profit. That is the difference between the revenue and how much it costs to make this, which is probably $16 to make it. It's probably like 10 really. But still, we're going to say $16. So the profit would be 25 minus the cost, 16. That's what we're doing here. But instead, we're using hypotheticals. We're saying, well, it's, 5 cents. And then I have an overhead, maybe $50, that kind of thing. Okay? So let's plug these two together. The revenue was 50x minus 0.05x squared minus the cost function, which is 0.09x plus 12,000. And we probably need to simplify this a little bit. And we should get the profit function to equal, it looks like it's going to be negative 0.05x squared plus 49.91x minus 12,000. Okay? You graph something like this, you're going to graph a function that looks like this, where we have a maximum. There is a certain amount of units sold. X is units sold, right? And there is a certain amount of peak profit. So if you can continually sell that particular amount, that's good. If you don't sell that much, you're not going to make as much. It's like a nice little equilibrium right there. Okay, can we move on? That's one word problem. Let's do another word problem. So this one was adding or subtracting them together. This one particularly was subtracting. The next one is a composite function. Okay? So this particular one states that the number n of bacteria in a refrigerated petri dish is given as n of t. Oops. N of t equals 20t squared minus 80t plus 500, where t is 2 less than or equal to t less than or equal to 14, where t is the temperature of the petri dish in Celsius. When the petri dish is removed from the refrigerator, the temperature of the dish is given by T of T. T, big T, little t. And 4 little t plus 2, where 0 is less than or equal to t, which is less than or equal to 3, where little t is time in hours. So find the composition of n of t and interpret its meaning in context. I think the first part probably easy, the second part's probably a little bit more difficult. Okay? So how do we do that? Well, we are going to take what t of t is, and we're going to plug it in for the big T. Okay? So we get n of t is equal to 20 times 4t plus 2 squared minus 80 times 4t plus 2 plus 500. Okay. So before we simplify that, let's just kind of interpret the meaning of this. Does anybody want to take a shot at it? What this function represents? Luis?
The number of bacteria and like how much, like, and the temperature of each of them together is like greater than equal to both of them.
Kind of. This would be the number n of bacteria in a refrigerated petri dish taken out of the refrigerator in terms of time. Okay? Not temperature. Okay? So, how many bacteria do we have after a certain amount of time when the petri dish is taken out of the refrigerator? Does that make sense?
You should label them.
I should label it? I don't know how. I don't know what that means. Anyway, let's simplify this. 20 caught me a little off guard there. 16t squared. This is 8 times 2. That's going to be plus 16t plus 4. And then I'll go ahead and just distribute this. 8, 16, 24, 32. Negative 320t minus 160 plus 500. Distribute the 20. That's 320t squared plus 320t plus 80 minus 320t minus, well, let's just do plus 340. She's right there. And then we're going to cancel these out because they do cancel, which is kind of nice. And we end up getting 320t squared, and we get plus 420. So that would be the number of bacteria after a certain amount of time. It's out of a petri dish. Is that good? That was A. B. Find the number of bacteria in the petri dish after 2 hours. Okay? Bacteria grow in the heat. So we would have 320 times 2 squared plus 420. We have 320 times 4 plus 420. That would be 1,280 plus 420. That would be 17,000 bacteria. 1,700. I wrote 1,700. Did I say 17,000? Sorry. C. Find the time when the bacteria count reaches 2,000. Oh my gosh. We have 2,000 equals, because that's what the number of bacteria are, 320t squared plus 420. We are going to subtract 420 from both sides. We will probably need a calculator at some point. And we're going to do 1580 equals 320t squared. Divide by 320. Running out of space, and then we're going to square root that. Do we need to do the minus square root? No, we don't, because we're not going to have negative bacteria. So whatever that is, or negative times, excuse me, whatever that number is, the square root of those. Somebody do that for me. I don't have a calculator in front of me right now.
Square root of 79 over 4.
Okay. Square root of 79 over 4. What's that number?
2.22.
Makes about, right? That makes about sense. 2.22 hours.
How did you get the 6? Oh wait, never mind. I wrote it down wrong.
Because my what?
Because your head is like right.
Sorry. She just told me I had a big head. I already knew that. We good? No?
So did you divide it by 2 and you did 21st, so you did square root.
Yep. Do we don't get the same answer? You should if you
The
just
answer doesn't make sense.
you're at 2 hours and
Okay, we're good.
okay. That's for C. Okay. Well, that was these problems right here on your homework. That's what we covered today. Let's see, how much time do we have? I can give you like 10 minutes to work on the homework assignment, and then we can move on to the other stuff.
Yes, move on.
Let's move on. No time for homework.
Time for homework.
Raise your hand if you would like time for homework. Okay, I have like half hands. Give me a good old-fashioned high hand. There we go. Okay, sorry guys. 10 minutes for homework. But it's gonna be a 10-minute exactly. So use it properly. So I want to break this video up into 2 spots then.